This video is on nucleophiles. Nucleophiles are not involved in the rate determining step of SN1 reactions. Therefore, they are irrelevant. As can be seen here, we have tert-butyl chloride reacting with either hydroxide anions or just water, yet they both will have the same rate of reaction. Why? Because the rate determining step is the loss of the leaving group chloride anion from the tertiary carbocation. However, in SN2, the nucleophile is involved in the rate determining step. So therefore, the nature of the nucleophile will affect the rate of the reaction. A key thing to look out for is that the less stable the nucleophile, the better. Think of it as our argument for basicity. We call that a unstable base is a stronger base because it's more desperate to form a bond. Well, same applies to nucleophiles. We'll go through some rules to figure out if you have a good nucleophile or a poor nucleophile. Rule 1. If nucleophilic atoms are from the same period, the strength as a nucleophile parallels the strength as a base. Rule 2. Nucleophilicity increases down a group, at least in polar protic solvents. We'll talk about solvents later. And rule 3, steric bulk decreases nucleophilicity. I.e., if you have a lot of branching, you're going to have a much worse nucleophile than something linear with no branches. Furthermore, bulky nucleophiles tend to be the best bases because they are unable to act as a nucleophile and only as bases. Right? So that's why potassium tert-butoxide or LDA are the best bases to choose when you need to use a strong base. Here are some practice problems. Which reaction will have the higher reaction rate? You may pause now. And here are the answers.